In this instance, we're going to actually add a synchronization pulse. We'll see how we can pull that from the ignition system. It's quick, it's easy, and makes the relative compression test much more usable in a failure scenario. The relay is already out for the fuel pump, guys, so we're just going to crank it over on the starter. Clearly, as the starter draws current, the clamp-on ammeter here is going to monitor that current, and clearly, as the engine goes through its compression cycles, it will require less or more current draw depending on the amount of load, obviously, as the engine goes through its compression cycles, and that's how we'll actually get trace. Okay, that should be plenty of rotations in order to get something decent. You can see on the trace that all the humps are really quite even. That's the important part. But as good as this is, we have no idea what cylinder is representing what. Now, in the case where everything's balanced and everything's healthy, it doesn't really matter. Let's see if we can make a bit more sense of this with adding a synchronization pulse. Clearly, the SX4 is a coil-on plug system, and you can see we have 3 color-coded wires. So it's the one wire color code that's different, which is going to be the individual trigger pulse. There'll be a ground, and each one is obviously triggered independently from the engine control module. So we'll tap that in channel 2, and of course the ignition trigger pulse doesn't come at top dead center, but it'll be close. So it'll be plus or minus the timing advance or retard, right? Close enough that we can get a good idea which piston we're dealing with respect to the compression hump in the current. Back probed that trigger line on cylinder number 1. You can see again that's the start of the engine rotation, guys, the first cylinder, and there is the trigger for the number 1 cylinder. So again, the firing order 1, 3, 4, 2, and then back to 1. So that is the beauty of having a synchronization pulse. You can now make a distinction in the trace with respect to what hump is what. That is the number 1 cylinder or piston actually loading up the starter as it goes towards top dead center. The rising edge here is where the coil is actually charging the magnetic field, and then this is the dwell time, and on the falling edge here, the trailing edge, whatever you want to call it, this is where the coil actually fires. Let's call that top dead center. You can see that's occurring just after. How many degrees we could figure out again with the cursors, but perhaps beyond the scope of this video. Up for a loss of compression, you'll hear it right away. So let me just crank and we'll see if we can get a sensible trace. I have narrowed it down to just a single trace, just to make the point that if there's an absence of a trigger sync on the trace, then its usability is diminished. You can see we clearly have an issue, and we don't have 4 compression humps, we have 3. So there's an extreme loss of compression. I'm taking it to the extreme to make a point, obviously for demonstration purposes, guys, right? But you can clearly see there is a big problem there. There is a complete absence of one of the compression humps. So by adding the trigger, this synchronize the trace, so we can apply the firing order and actually make a distinction what cylinder is actually the issue here. I don't think you need a scope to know there's something wrong with that crank, huh? Okay, again, the beauty of having our trigger actually in here, our synchronization, we know that this is cylinder 1, so we can plug in our firing order. We know that the firing order is 1, 3, 4, 2. 1, 3, 4, 2. So it looks like we have an issue with cylinder 4. Do we have an issue with cylinder 4? Yeah, I think so. Since the coil and the plug have been completely removed, we have a dead hole for the sake of the demonstration here, guys. Right, so again, this is not difficult. This is quite easy to do. Quite easy to do. We can make that distinction. We can make that call that is 1, 3, 4, 2. That's it, boys. I hope it made sense. Cheers.